In any modern data center, trying to get your application traffic through a firewall or a load balancer, well, it can be a real nightmare of complex routing and messy cabling. Today, we're going to dive into Cisco ACI's really elegant solution to this, the service graph. We're going to break down exactly how it automates inserting these critical services, turning what used to be a huge networking headache into a simple, policy-driven workflow.
All right, here's our game plan. We'll kick things off with a quick look at why we even need service graphs. Then, we'll walk through the 4 key configuration steps: defining the devices, creating the graph template, applying it all with a contract, and finally, the fun part, letting ACI render the policy. Let's jump right in.
So, before we get into the nuts and bolts of the how, it's really important we're all on the same page about the problem we're trying to solve here. In traditional networks, if you wanted to steer traffic through a firewall, it usually meant making complex and, honestly, pretty brittle routing changes. ACI service graphs completely change the game by abstracting and automating this whole process. Service insertion becomes a function of your application policy, not the physical network topology.
Okay, so this diagram, this is pretty much our blueprint for everything we're about to do. On the left, you've got a client in one endpoint group, an EPG, and on the right, a web server in another. Our goal is dead simple. Make sure all traffic between them has to go through that firewall in the middle. The service graph is the tool we use to define that path. And as you can see from the callouts, it's basically a 4-part recipe. First, we define the device. Then we create a graph template for the traffic flow, apply it with a contract, and finally, use a device selection policy to link our logical plan to a real-world device. This is the exact blueprint we're going to follow.
So the entire configuration, from just an idea to a fully deployed service, really just boils down to these 4 main steps. First, you tell ACI about your service appliance, your firewall or load balancer. Second, you draw a logical picture of how you want the traffic to flow. Third, you decide which specific application traffic needs to follow this path. And fourth, you point ACI to the actual cluster of appliances that are going to do the work. Let's dig into each of these now.
All right, let's get into our first step and see how this all starts to build out. We have to define the service device itself right inside the ACI fabric. This is where we introduce the appliances, whether it's a firewall, a load balancer, or maybe an IPS, that are going to be doing the actual work.
First, and this is super important, we need to get our heads around 2 concepts ACI uses for abstraction. A concrete device is exactly what it sounds like. It's a single, real firewall, whether it's a physical box or a VM. But here's the key. ACI policies don't talk directly to these concrete devices. Instead, it groups them into a logical device, which is basically a device cluster. This logical device represents the service as a whole. It's a huge deal for scalability and high availability, and it's this very first step of abstraction that starts to separate our policy from the physical world.
And here's what that abstraction looks like right in the APIC, which, is ACI's controller. In the Create L4, L7 Devices wizard, you can see 2 clear steps. First, over on the right, you add your concrete devices, your individual firewalls. Then you group them together down below into a logical device cluster, you give it a name, and you define the logical cluster interfaces that our policy is going to use later on.
Okay, so we've got our logical device defined. Now we get to the really cool part, the heart of the service insertion logic. We're going to create the template that dictates exactly how we want traffic to be treated, and it's completely independent of the underlying network.
So the crucial point here is that the service graph template is basically a reusable blueprint. I want you to think of it like a drag and drop canvas for your traffic policy. It's not tied to any specific application or any specific device just yet. It's pure logic. It's made up of function nodes, that's our firewall service, and terminal nodes for where traffic comes in and goes out, all stitched together to define a path.
And this is literally what that canvas looks like in the APIC. It's actually incredibly intuitive. On the left side, you've got your library of logical devices that we just created. You literally just drag that device cluster onto the canvas and drop it right between the consumer and provider nodes. This simple action is what creates our service chain, telling ACI to direct traffic from the consumer through the firewall and then on its way to the provider.
A template is just a blueprint, right? It doesn't actually do anything on its own. The next critical step is to apply it to a contract. This is how we take our abstract traffic flow policy and start to enforce it on real traffic flowing between specific groups of endpoints.
This is a really, really important distinction to get. The contract, it's the selector. It defines what traffic is subject to the policy. For example, it might say, allow HTTPS traffic between the web EPG and the app EPG. The service graph template, which we then attach to that contract, specifies how that selected traffic gets processed.
In our case, by getting punted over to a firewall. The two pieces work hand in hand to create the complete policy.
So here in the wizard, this is where we start connecting the dots from the logical to the specific. First, we define the scope. We select our consumer EPG, in this case it's an external network, and our provider EPG, which is the internal Exchange server. Then, under contract information, we associate this whole interaction with a contract, like FWS-RCT that you see here. This is the step that binds our abstract graph to these very specific application tiers.
In this slide, this is where we see the network plumbing start to happen. It's brilliant, really. We have to configure the consumer connector and the provider connector by mapping them to the correct bridge domain, or BD, which you can just think of as a Layer 2 network segment. This tells ACI, hey, the firewall's consumer-facing side needs to connect to the Sales DB BD, and its provider-facing side needs to connect to the Sales Exchange BD. This is how ACI begins to automate all that network stitching for us.
We are so close. We've defined our logical device, we've laid out our logical traffic flow, and we've attached it to specific endpoints. The final step is to make it all real by telling ACI exactly which device cluster is going to perform the work. And this is what kicks off the best part, the automated rendering.
This is it, the final piece of the puzzle, the device selection policy. You can think of this policy as the explicit instruction, the glue that connects everything we've built so far. It says, plain and simple, for this specific contract and this specific graph, I want you to use this particular logical device cluster. It's that final mapping between our abstract policy and the concrete resources that will actually enforce it.
So if you look at the APIC UI, it's pretty straightforward. We just navigate over to the device selection policies for our tenant. Here, we create a policy that explicitly links our contract, FWCT, and our graph, FWSGT. The final, absolutely crucial step is selecting FW from the dropdown. That's the logical device cluster we built all the way back in step 1. And with that single click, the entire logical construct is complete.
So, the big question is, we've defined this whole policy, right? How does it actually become a real network configuration? Well, this leads to the most powerful and, frankly, the most magical part of ACI service graphs, the automated rendering process. We've given ACI all of our high-level intent, and now the controller is going to do the hard work of translating that intent into concrete configuration with zero manual intervention.
I want you to think of the APIC controller as this big engine with a bunch of gears. We feed it our logical inputs, the graph template, the logical devices, and the contract. The rendering engine takes all these pieces, starts turning those gears, and the output is a fully deployed and configured service graph right on the fabric. The firewall gets plumbed in, routing is adjusted, policy is enforced, all of it, automatically.
So what's really going on during this rendering process? Well, ACI is basically translating our policy into reality. The controller is automatically allocating the necessary VLANs to connect the leaf switches to the service device. It's programming the forwarding tables on the switches to redirect the traffic exactly where it needs to go. This is the automation that saves countless hours of manual, error-prone configuration.
And if you could peek under the hood, what would this automated plumbing actually look like? Well, it's pretty slick. ACI creates these things called internal EPGs and internal contracts. As you can see, the traffic doesn't just magically jump from the consumer EPG to the firewall. ACI actually creates a brand new internal EPG for each firewall connection and uses internal contracts to allow the traffic. This is how ACI can transparently stitch the service into the path while keeping the integrity of the overall policy model.
All right, let's bring it all home. What we've really just seen is a fundamental shift. ACI takes the complex, manual, often frustrating task of inserting network services and transforms it into a logical, highly automated, and policy-driven workflow.
So when you follow this 4-step policy-based workflow, what you're really doing is creating this powerful, automated way to integrate services. You start by abstracting your devices into logical groups. You create a reusable template for your service chain. You apply that policy to specific traffic using a contract. And finally, you link it all together and let ACI's rendering engine handle all the complex heavy lifting of deployment.
And that really brings us to our final thought. The big takeaway here isn't just about saving a few hours of configuration. It's way bigger than that. When you move from a manual topology-aware way of inserting services to an automated policy-driven model, you truly decouple your application security requirements from the underlying network. And that unlocks a whole new level of agility, letting you design and secure your applications faster and more consistently than you ever could before.
Thanks for joining me.